Hello and welcome to video 2 of Just Another Statistical Program or JASP. In this video, we're going to talk about how to run descriptive statistics, how to create a histogram and box plot charts, how to run a one-sample t-test, how to apply a filter, how to run an independent samples t-test, and how to run a one-way ANOVA. So clicking back over to JASP, we had imported the data set. We had created the different variables, put in the labels. We can kind of see all the labels there. Everything looks good. So we're going to go ahead and do this. I'm going to close out of that part. And now we're going to ask a question about the mean of a variable. For most questions you have about your data, you'll probably want to look at descriptive statistics, then look at graphs, and then run a statistical test. Let's say, for example, you had data from the 1930s indicating the average country had a corruption level of 5 at that time. We'll find the descriptive statistics for corruption reverse coded in our modern sample. We will visualize the data using a histogram, and then we'll run a statistical test to determine whether there are differences between the historical dataset and the modern value were statistically significant. We will hope that the test below reveals a low probability of the estimate given the null hypothesis is true. So a p-value less than 0.050 or less than 5%. Now p-values do not tell you whether the result was based on random chance or the reproducibility of a result or the size of the effect. It will just tell you the probability of the estimate given the null hypothesis is true. So first we're going to do is we're going to get descriptive statistics. We're going to click on this descriptives icon. And notice how this new panel came out. I'm going to go back and forth. We can click on this little arrow. And that's going to slide it back and forth. You can also drag out with these 3 dots here and resize it if you want to see both of them at the same time. So I'm going to go ahead and do it this way. You can also, that's where you don't want to create a new column. So let's go ahead and just keep it this way for now. So to get descriptive statistics, I'm going to go ahead and find our corruption2 variable. Now move it to the arrow to add this corruption2 to our variables box. It's already went ahead and it created descriptive statistics, how many valid cases we have, the amount missing, the mean, standard deviation, the minimum and maximum scores. Now I'm going to go ahead and click on and expand this plots option. And then from this, we can go ahead and click on box plots. And that will tell you what's the lower 25%, the middle 15%, the distribution, and the upper 25, and the median, or the middle value. We can also click on distribution plot. And this will create the distribution, or the histogram, of corruption2 scores and how many counts we have. So this tells us a nice little thing about our data. I'm going to go ahead and expand on the statistics box, and we're going to get some more information. I'm going to request the median. I'm also going to ask for skewness, kurtosis, and let's get the variance here. So looking at this, we have the mean is 5.96 with a standard deviation of 2.16. Looking at the kurtosis and skewness, there is a little bit of some skewness there, but it's not too bad. It's still within a range of plus or minus 3, based on Glassnap and Paggio, 1985. And our kurtosis is about 0.4, which is below a potential kurtosis value of 10, based on Klein, 1998, I believe. So within this, it looks okay. It's still not exactly what we're looking at the visual. But what we're going to do now is we have our descriptive statistics. And note that our mean is 5.96, which is higher than the 5 from the 1930s. What we're going to do now is we're going to do a one-sample t-test to compare if that sample mean differs from the set value of 5. To do that, click on the icon t-test. In classical means null hypothesis statistical testing. We're not doing anything with Bayesian today. Let's go ahead and click on one sample t-test. I'm going to go ahead and scroll down, and our outcome variable is corruption 2. I'm going to move that to our variables option. Notice because this is saying it's a quantitative or a continuous variable, that's what it has to be for this type of outcome based on this lower corner. And then what we're going to do is we're going to go ahead under test, make sure that student is checked. I'm going to change the test value to 5. That's what we're comparing it to. Because I don't have an a priori hypothesis of whether it's going to be above or below, I'm going to go ahead and choose the not equal to value. Under additional statistics, I'm going to ask the effect size, descriptives, and descriptive plots. So looking at this, this is our cutoff, that 5. 95% confidence interval around this, so if we repeat this an infinite number of times, 95% of the time we'd expect to see an estimate between the upper and lower bound. We'll go ahead and get that right now. So the lower and upper bound of the difference within there. And there's our mean score. Now looking at this, our t-value is 5.57 with 156 degrees of freedom. The p-value is less than 0.001. So because it's below that 0.050 threshold, we're going to reject the null that there is no statistically significant difference between the set value and our sample. The effect size is at 0.44, which is about a moderate effect size. Great. And notice how whenever we do a new test, we have our initial one up here too. So we can always go back to it too. So it's all there. We can make changes and it's dynamic. We can also do things like add, we can get some more information. So if you click on this information, it tells you the assumptions, and it tells you a lot more about these and some information that's really helpful here too. So it's really, really great. So now what I'm going to do, if you wanted to remove that, you can also click here to remove. And you can also edit the title here too. So if you can change this from one simple t-test to comparison of 1930s if you wanted to. So it's pretty flexible. Let me actually do that. And by doing that, that also changes the header here under the t-test. Great. So now what we're going to do is we're going to compare the means of two different groups on how well the economy is doing. So we're going to try to determine whether differences in GDPPC are based on the corruption categories that we recreated earlier. We'll explore to determine the mean GDPPC for each category, create a bar chart, and then run a t-test and ANOVA to explore those differences. So the first thing we're going to do is we're going to obtain GDPPC scores by corruption categories. We'll click on descriptives. So we have another descriptives. I'm going to go ahead and I'm going to rename this to GDPPC by corruption categories, just to make it easier if you want to export this over. And now I'm going to go ahead and find our GDPPC variable. I'm going to move that here. And we're actually going to split corruption categ and split that out. So now we actually have the GDPPC information for low, medium, and high, how many countries. We're going to have what the mean is for the low group, the mean for the median, and the mean for the high group. We have our standard deviations, minimums, and maximums. Under the statistics, I'm going to expand this. I'm going to ask for the median, skewness, and kurtosis. Skewness doesn't look too bad. There's a little bit more kurtosis, non-normality with the low one, but it's still within range. So I'm going to let that be. So looking at this, low has the highest average GDPPC, medium has the middle, and high actually has the lowest average GDPPC scores. If we click on plots, what we're going to do now is we're going to go ahead and choose box plots. So when we look at that, we can actually see the distributions of GDPPC for low, for medium, and for high. Now we have one low corruption category that has a really, really high GDPPC. We would maybe want to look at the data, figure out what country that is, and then maybe run the analysis with and without them to see the impact on it. Now what we're going to do now is we're going to compare the means of two groups and only two groups using an independent samples t-test. Now the t-test is the most basic way to compare two groups based on the scores on a single variable. While we divided corruption 2 recoded into 3 groups, we can only compare 2 of those groups at a time using a t-test. So the first thing we want to do, I'm going to click this tab over to go back to our data option. I'm going to use corruption category. I'm going to click on that, and I'm actually going to uncheck medium. So actually that's filtered out all the countries that have a medium. So we just have high and just have low. Now it's omitted, but we still have that information there. It's just not going to use it within the analysis. So we've filtered out those cases. I'm going to hide the data view, and now I can actually go back. I can move that over there. You can also drag this in reorder if you want. I'm going to click on t-test. Now I'm doing an independent samples t-test under classical. I'm going to go ahead and take our corruption 2 because it's only 2 groups now. It will run it, otherwise it would throw an error message. I'm going to go ahead and put GDPPC as our test variable. Great, so now what we're going to do is we're going to go ahead and also click on the Welch test. And this is if we violated the equal variances assumption, so the variability in the low group should not be statistically significantly different than the variability of the high group. If we reject the null, which the null is that there's no statistical differences in the variability, if we reject that, then we actually have to use a correction. Since we have no a priori hypothesis, I'm going to choose the not equal to for the alt hypothesis. Assumption check, I'm going to go ahead and choose equality of variances. I want an effect size. I'm going to choose Cohen's d. I want descriptives and descriptive plots. So before we look at the independent samples t-test, we have to look at Levine's test, the equality of variances. Based on this, we've rejected the null hypothesis. Our p-value is less than 0.050. We reject the null in favor of the alternative. So because of that, we have to use the Welch test. So the Welch is statistically significant. The statistic is 15.29 with 23.4 degrees of freedom. We've had a substantial loss in the degrees of freedom because we violated that assumption. It is still statistically significant, so we're rejecting the null that the mean of group 1 is equal to the mean of group 3. And the effect size is huge. That's a really large effect size. If we scroll down a little bit, here's our descriptive statistics that we saw earlier. And here is the differences between the means. Here's our low group. Here's our high group. Great. So now what we're going to do is we're going to run a one-way ANOVA F-test to compare the means of more than 2 groups. Before we do that, I need to switch back over to the data view, so I'm going to show the data. Go back to our corruption category, and I'm going to check medium. That's bringing medium back, so we're removing that filter. I'm going to close out that variable view and go back to the analysis panel. Now what I'm going to do is I'm going to go ahead and go to ANOVA. Now I'm going to click on Classical ANOVA. What I'm going to do now is I'm going to go ahead and scroll down to our corruption category. That's our fixed factors. So that's our grouping variable. And I'm going to move GDPPC over to our dependent variable. I'm going to go ahead and ask for descriptive statistics for each of the groups. I also want estimates of the size, and I'm going to ask for eta squared as an effect size. From here, what we can then do is we're going to click on the assumptions here. Now I'm going to ask for homogeneity of variance test. Before that, we violated that assumption. We violated it here too. So I'm going to ask for a Welch correction. That way we can see, accounting for that violation to the equality of variances, this is the corrected model. The Welch one is the one we should be using for that. So again, we have a reduction in power due to the reduction in sample size, and now that's also going to impact the ratios, creating our F statistic. It is still statistically significant, so the mean of group 1, so the null is the mean of group 1 equals the mean of group 2 equals the mean of group 3. If there's any difference in there whatsoever, we're going to have a significant ANOVA. And then we have to use a post hoc to test to figure out, okay, where are those specific differences? Now to do that, I'm going to click on post hoc test. I'm going to move corruption catig over here. And because we violated the Levine's test, I'm going to go ahead and do a games howl. And then we can actually compare here. So here's our post hoc test with the games howl, the low to medium group. That is a statistically significant difference. Same thing with low to high and medium to high. These are all statistically significant differences here. I can get the confidence intervals around those and flag significant statistics there. I'm going to go ahead and click on descriptives. And we can also do, so I'm going to go ahead and move corruption catig to our horizontal axis and display error bars. So now we have the error bars, or not the error bars, we use confidence intervals. You can switch over to error bars if you'd like to. Now use the different estimates for it. For now, we're going to go ahead and use constant intervals at 95%. And then we have our mean, or 95% constant interval around those means for each of our 3 groups. So based on this, we do have statistical significance, and we can say, like with the post hoc test, each of these are statistically significantly different from one another. We're going to end this video here, and we're going to pick up looking at the relationship between 2 continuous variables in the next video.